In this video, we're going to talk about just some general tips for graphing data, and we're going to do this by looking at a specific example. Imagine that we have taken some data for a cart moving in a straight line, and so we have a table with some data here that is a time and displacement, and we've taken some data points and they're not evenly spaced, as you can see here, from time equals 0 to time equals 10 seconds. And we're going to graph this data. So what is the first thing that we need for a graph? Yep, so the first thing that goes in a graph is its title, and the title needs to be a full description of what that data is. So in this case, it is the displacement of the cart as a function of time. Now, in order to actually start graphing up this data, we need to have some axes. And the axes tell us something about what variables we're plotting. So here are our axes. But of course we need to label the axes with the variables and the units. And this enables the reader to be able to look at those axes and figure out what it is we're trying to say. So we've got distance or displacement along that vertical axis and time along the horizontal axis. Now we need to have a scale on each of these axes, and the scale needs to be uniform. But what do I mean by a uniform scale? Well, to demonstrate that, I'm just going to plot up the time points that we have in our table, just one after the other. So here's 0, 1, there it is, 2, 3, 2, 4, 5, and 10. Now you can see that each of those time points has a different spacing between them on these axes. So this axis does not have a uniform scale. So we're going to remove that. So rub that out, rub it out, and start again. So we're going to draw a uniform axis where each of the time marks are an even spacing apart. So there you go. We have 10 divisions on that scale, and each of them represent a duration of 1 second. And then, of course, we need a uniform scale on the vertical axis as well. And notice there that I have put the displacement going into the negatives as well, because we have displacement as a vector, and it can be on the negative side of the zero displacement, or it can be on the positive side, just like a number line which goes into the positives and negatives. Okay, so point number 3 is that we need data points. And so I'm going to draw for each of our time points that we've got on our data table there, I'm going to draw in the displacement at that time. So at 0, it's a negative 0.8. At 1, it's 0.2. At time equals 2 seconds, it's 0.3, and so on. We also want to demonstrate on a graph how uncertain we are about any particular point. Let's assume that our uncertainty on the time is very small and we can't really draw it in very well, but we will draw in the uncertainties for the displacement. We draw them, so we need to put in error bars, and we draw them as little lines. Oop, I've just added up the top there that it's 0.2 meters is the uncertainty on each of those displacement points. And so we'll put them in. And each of those bars represents the range that that data point might actually lie in. So it could lie 0.2 above, or it could lie 0.2 below that red dot. So usually when we're looking at data, we want to interpret it in some way, and often we're looking for trends in our data. So we're going to draw a line of best fit, and in this case our line of best fit is actually a line. It's not a curve of best fit, it's a line of best fit. So we can draw a line of best fit which tries to approximate or represent the trend that that data shows. I'm going to demonstrate to you now how a child in primary school would draw a line of best fit. So here we go. When you're in primary school, you join the dots. This is not how we draw a line of best fit. Joining the dots does not show us the trend of the data, it just joins the dots. So what I'm going to do is remove all those segments there, and we're actually going to draw a line through our data which shows the trend of the data. Now, I hope this doesn't sound too much like an excuse, but it is rather difficult to draw graphs on a screen like this. When we're drawing lines of best fit, the line should go through the middle of the data, and you should see kind of about half of the data points on one side, half on the other, but that data should be randomly scattered on both sides, so it shows that general trend. Now, I'm not sure that my line is fantastic, but those are the kind of guidelines that you should follow. And just another reminder, do not join the dots, ladies and gentlemen. That is for primary school. Okay, there are some basic graphing tips as a reminder of how we approach the presentation of our data.